Whether we do C ABI compatibility or work on the build system. What do you want to see? So I'm up for anything here. Whoever's in there who wants to watch something in particular, let me know. So what's missing here in the program is obviously these, right? So we have a lot of fun things to do if you want to like compile and run. There will be, I don't know, I have a lot of things. I don't remember what these should be doing, so I'll have to look at the specs. But I could also do the C ABI. Any opinions? People watching? The C ABI is fun and hard, and I will only go get like a little bit through that. So maybe I should have a look at that. So let's see how that looks like right now. Okay, so that is that. So attribute sections. And you add the function, and then you add a lot of. Hang on, this can't be it. Oh yeah, now I remember. All right. So I guess I'll actually look at the C ABI. If no one minds that, or just let me know if you prefer that I work on the rest of the system. There is quite a bit of cleanup that I could do. But let's think about the C ABI. So this looks like I'm generating the function, but actually I'm just using the type that I already made for this. And so the code isn't actually in the type when you create the prototype for the type. So this looks weird. Let's see if I have it right. So here it is. So this is the right one, right? So I will create the params, and maybe there's a return param, and then we have some things, and then we put it into the create a type for that. And then when we make the calls, we'll I like at this point here. Let's see here. So why is there a return parameter? A return parameter is when it realizes that like this. So okay, so it's failable or there is a return time. In this case, we need to have a return type. So we return things by return this, like if you have something like this. I'll give an example. So we have something like this, foo, get foo, right? Oops. Now in this case, if foo is, if the size of foo, if you think about that one, is in C, if this one is greater than like 128 bytes on a 64-bit platform, and this will be put as this one will be like transformed implicitly into something like get foo and like the foo return and foo, and then when you call it, you will create a foo and pass the pointer to it. So you have to, like on the call, the caller needs to allocate some memory for foo and then return a pointer to that pre-allocated foo, and then what the function actually does is to fill out this return foo. But that is just like a small thing, and I mean, I think that, like, to me, if you say like tell LLVM that you want the C convention, I think like the natural thing would be like, okay, you want C, we'll give you C, but that's not what happens. So let me just get to the docs call convention, and hang on, I'm just going to swap here, like in the reference manual. I'm going to swap. Let's see if I can't change the window somewhere. I'm not all that used to. Oh, there it is. Okay, so how to change window? And maybe I can just edit the layout somewhere. And no, that was not possible. All right. Change capture, please let me know how I do that. Oh, just to go. Right now, I'm having some problem changing what you see for some reason. Please. Let me show you now. So, all right, we're going to go here. Okay, so when you do the back end, you think that maybe everything is in here. So what you want to decide to do is, yeah, I just want to call a function, and that's something you do a lot. So why don't I just call a function? Right? So you define a function, something, and then you have the where is it? So the calling convention, and you pick the C calling convention, and you're done, right? Or not, because this doesn't actually work. Not if you have structs. I'll just show you a bit of Godbolt here. So let's say we have like a foo. It's taking a foo instead of this. Let's just return 1. So you're gonna. I want to define here. Oh, C++. That was bad. So let's pick C, because otherwise we get a lot of other stuff. Type def some struct. We'll call that foo. And we pass a foo and return 1. And I want to get Clang here, because then I can show you the IR. So, right, this looks fine. It's not doing anything because there is nothing in foo. Okay, but let's put something in foo. Now it's an x. Ah, look here. It's not passing foo, it's passing int, right? But if we make this really big, right? What I talked about before was, let's say we make this pretty big. And now it wants to do this by a value. So if I call that from another function, like I call test, and then I want to, get a, let's see, I want to do something like this. I have a foo, f, which is like something, it's empty. Or I just set the x to 1, so, right, as there is something. And then I want to do like square f, right? Now, as long as we get something. Okay, so what we see here is that we're going to create this foo, but then we send it by value, even though it looks like we sent it by copy, right? And if we do something here, so we say x is 2, okay? Then up here, oh wait, is it allowed? Hang on. If I'm storing, this is the call, this is the foo, and I get that by value, and now that it's changing things in foo. All right, I didn't expect that, but I think that should be that's something. I do it by val, and I guess this is creating something implicitly, a copy implicitly here. Okay, but anyway, now we're doing something. We want to look at something else, like what happens if, remember this one? You said, like we said, okay, just have x. Why did that break? So let's try that again. All right. So now we get this one, right? But then we have allocate a struct, and then we take a pointer to that, and then we take the parameter and we store that inside of foo, right? But it will get weirder. Let's say we have a float here. Float y. Now we'll have, ooh, what is that? Right? So now suddenly look at what the signature became. Like, what the heck? And we can actually do this differently. Let's make x, we can make x this x, right? Now there's a float. Ooh, and then let's make it a double there. I think we'll get a double in the float. So one would think that you could just say, like put foo there and everything would work, but at least Clang is not doing that, and you can't, we should also look at, this was just, okay, so if this was all there was, then we would be fine. But let's take ARM v8. What do we get here? Something completely different. And let's say we remove that one, now we have double. It's a double. But if we have, what happens if we have two doubles? I don't know. I haven't tried this yet. Oh. And if we have another one, it should spell, I think. So we get like, oh no, it's actually sending three doubles. Great. So this is not conforming to like what I did before, when I said like this is going to, I just put that in like on the return like a by val, because this is clearly not doing that, right? Because it's like doing a load, and then we gladly get this and do the call with this the content here. But if we go back, let's do this Clang again. Now it's by val, and then we RV. Let's see what that was. Okay, it's the same thing as V8. Let's see if we can get something else that has LVMIR. This one looks interesting. So this one is giving a double again. Can we get something else that's like doing Clang-ish stuff? Oh, this one was fun. So here we get the that was a weird word sound there. So here we get the struct, right? But in this case, let's see what happens here. So we're doing a mem copy to that. So again, we are creating a couple of things. Like first we create the first one, and then we do a mem copy to the foo, and then we send that one. Look at this is not by val. Why is that not by val? I don't know. It doesn't make sense to me, but that's the way it is. And if we have 64 bits, then it's like that. Let's see what happens if we remove that one. It sent us that, okay. But if we do this, then it would be by val. That makes sense, okay. But ARM V8, ARM V8, ARM, that doesn't make sense to me. But that's the way it is. All right, so let's see what we can get by looking at Clang internals. So that's like the only way we can get somewhere here is to consult the Clang internals. And I found some suggestion that, oh, I am sorry, I have a telephone call. I need to pause this a little bit. I'll be back. Jag ska på göra en sak. Är du inte hård bara du pratar eller något speciellt? Ja, du kan ringa en timme så här. Jag går ut och går då. Ja, okej. And I'm back. Okay, so I had some suggestion that the thing you should look for was, hang on, I know I have some somewhere. Okay, so we want to go to basic targets and code-gen target info in Clang. That's interesting. So I could do this in Xcode, or I could just jump here and let's see if we can get this Clang. I don't know if this works. So we got it here. So this is where now here you got all the targets, right? And let's see what we can figure out from this one. Okay, here we get all the targets. Yeah, that's fine. And then, yeah, it doesn't really help much looking at this, I guess. Format unit, features. Okay, so that didn't help. That was targets, right? And let's look at a particular target. Here is ARM. All right, so there's something about alignments. And this is some particular, no, this is not this particular target, it's the ARM CPP. Okay, and then some more architecture function. Okay, and then all the different types. That's fine. And the target info, and set it as generic ARM in the ABI. So use the generic ABI information. I don't know if this is, if anything else is sort of put here. All right, there is the registers. And there is the call conventions. And they are ignore those, and they are okay with those. So these are the valid call conventions for this particular, and we're going to set it as these are the APIs apparently. So depending on we have this one, we have the generic ARM. So let's look. What is this? Generic ARM is okay. This is all you got from that. There it is, the definition. Let's see what we have here. All right, so I guess this was it. Now, next thing we want to jump to see what really happens in Clang should be somewhere here. I guess this place is good as any to jump into this. Okay. How many lines of code is this? So roughly 10,000 lines of code to handle target info. There are other implementations, and those are smaller, but I guess this is where you want. So got to take some notes here. Even like it's going to check if it can pass things in registers, right? Let's see what that means. I think this will load too. I mean, this is like you hate this because like everything is okay. Let's get into this and then jump into the next one. And this is just going to be a lot of jumping. I have to open Xcode or I won't be able to jump back and forth through this. Right? I'm not even sure, I'll get anywhere with this, but getting somewhere is like basically you have to start somewhere, and then trying to get to some place a little better than before. So I'm just going to swap now so jump to the Xcode window. That flashed, and then Twitch Studio didn't want me to change that after all. Right. Yeah. Twitch Studio is really acting up. There you go. You have to like tap it and then really be really careful what you do. So now we're on Xcode instead. Oh, this was pretty big font. I have. Oh, now that's not revealed too much there. I don't know where I can fix the font here immediately. Anyway, okay, so we have to live with this. Right, okay. So where were we? We were in the target info, and then we're going to, let's see here, we were in the target info source, right? The target info CPP. target info CPP. There are two of those. There's a basic one, and there's, let's see what this one is. So here seems to be like some basic stuff. This is not the 10,000 lines. Yeah, so this is just simple stuff. This is basically, does this architecture have these types and so on. So let's see if there's something nice that you can glean from this. Calling conventions. Nah, I'm not supporting OpenCL. Clubbers, there's something you need to, if you want to like parse the assembler, you have to know about those if you want to check those in your compiler. Another huge thing to add. Right, those are the constraints on the registers, and you don't need to look at those. Blah blah blah. So there was nothing useful here really. Okay, so then there's the other one. I guess this one is the big bad one. Oh boy. All right. Helper for querying an aggregate argument to return value only for Redder script ABI. Okay, right. So this is not what we want. Let's see here. So it occupies more than. Okay, Swift. So so here we are with this could pass in registers that we're looking at, and then okay, just goes to that one. Arg passing restrictions, and there are, yeah, that was probably C++. Let's say it is. Yeah, this one is just for so it should be default. I think at one point in time actually you would just strip this down to just try to see what the C was. And if it's a transparent union, then we can do the first element. Okay. All right, varargs, we're not going to do that right now. Like the problem is that like there's a lot of complexity for C++. So we also, trying to figure out what Clang is doing is like also having to look through whatever you do for C++, which is like an insane additional amount of things. Dependent. Let's see. I mean, I'm still looking for. We're up here, right? Let's. This is no way. There is no way we're going to find it this way. So I had to like look when they emit something. Emit. What can it be? A cogent function. Right. So you want to cogent function something. Per function state when it's no. I guess I just have to, look here. Kudos to everyone who's actually been through this and tried to make sense of this, like before me. It's not really all that simple. I don't even know if this is the right place. No, this is the LLVM code gen. Should be Clang, right? Where is Clang? this LVM code gen. We were in the I forget which there it is. So Clang something. Clang libraries, Clang driver, Clang ABI. And this is like in the Clang libraries. So this is the latest version. Oh, here we are. So we are in Clang. Clang, tidy. You probably see this before I do. So in the here's the Swift calling convention. I don't care about that one. I just want to see where that one is. So navigate, revealing project, navigator. So here we are. Right. Wonder if there's like a calling convention for something else. No, this is just the Swift calling convention. Wouldn't it be nice to have like the calling convention here? So codegen ABI types, free function type, CXX method type, arrange a free function type. Arrange, we jump, I mean these are, I love these levels, so like seemingly doesn't do anything. And we go down into this arrange function info, and then we do the blah blah blah, we find a node, we convert the call convention. Right, so now we want to construct the function info. And there is some stuff here as well. Okay, so we want to, now we down into, deep into the unknown. We are going to create a function in Clang. So we set all this information. Now we have the args, we have some parameter BF buffer info. Okay. Now we have a lot of interesting things here. So okay, so we send in an ext info. What does the ext info contain? It contains the calling convention. It contains reg params. It contains volatile. Right, and then we have this no prototype one. Right, so we are here, we have something, and now we want to create like produces return. Produces, this is probably just a void. No caller saved regs. How does it know that? So no caller saved regs. Okay. It seems I'm back to like the beginning of everything. I know this is not the place where you want to go. It's somewhere deeper than this, because obviously I'm in the just the H file there. So we got to dig deeper. These are hello files. Let's go and cogen function something. Gen ABI types. Maybe it's here. Actually. No. No, this is just like a dispatch. Completely meaningless. Right, so, oh here, I think this is like, okay, this is probably it, somewhere here. So, cogen function. Make national, like all I want to do is like see what the what it does differently for RMV8, right? So I'm here, somewhere over the rainbow. And I mean, this is 10,000 lines, so let's see if I can go faster, but it's hard to read. I mean, I don't know the code base well, so reading this, like reading a book, is fun. Sanitizer code, oh, of course that has to be going here as well. C++, san checker. Are we still in the same var annotations? Let's go faster here. So the var annotations could probably null initialization. Let's see if I have some way of actually convert type for man, emit function body. This is a scary thing. Insert helper. Field annotations. Like I want to start somewhere and generate code. So let's see. It's going to build a func arg list. Right. We get the return type. If it has a return, and it's a mostly derived return, whatever that is. In that case, we want to build that param. What does that mean? Build this. Oh, it says this, of course. So if, like in this case, there's a this pointer. Yeah, and then I hope this is the correct place. So they are reusing this probably for methods and functions. And then there's some constructor stuff, and we can skip that. And there are pass parameters. Okay, this was not the right one. This is so this was not anything interesting, unfortunately. And this was the body, right? So this was dead end. Emit global function declaration, arrange global function. And this should be it, right? So arrange structure, arrange function declaration. So apparently, maybe this one is the actual thing. Method is not a method, so when declaring a function with a prototype, always use a non-variant, blah blah blah. So let's go inside here and like assume this is true, right? So maybe something good will happen. Now we have two places. Oh, this one is this is cool. So folding set node. Oh, and profile this, I guess. I don't dare to think about what that is about. And then here, and then we go. Haven't we been here before? I'm pretty sure we were here before. And now we created the info, and that's actually not doing anything, I think. How are we doing? Inserting a node, blah blah blah. And we're going to compute info. If it's a spare kernel, use that. Otherwise, we're going to compute info. Ooh, I think we have it. Here we are. Maybe. So let's see. We know that the x86 is going to do some fun stuff. So here we are. So and it's going to do the Win64. Let's just look at the other one for now. So here are the free int registers. Oh, that's interesting. So we're actually going to have to track the number of assigned registers. I am already like delirious with happiness when I see this. Okay, then you want to classify the return type. Let's. Why can't it return? Why? If it is, I don't want to deal with this. Actually, I always want to see if the blah blah blah. What happens to the arguments? So we have an argument list. Here is something. Once the arguments are classified, the register is assigned left to right order. So classify a reg struct type imp. So if it has a flexible array member, what does that mean? Okay, so it can't be contained in arrays if it has a flexible struct member. And then it's a dynamic class, it won't be. And they're on the basis, right? Sum up the members. So if it's the record type and it's not in union type, then we're going to structure that. I want to go here. Again, check that. Okay, do we just come back to the same thing, right? And classify argument type. So here we have something like classify. No class. Okay, so if it's an float double, then it's an SSE. If it's a quad, then we have SSE or low is SSE and the high is. Alright, so let's see here. So we have low and a high part. And if it is anything up to a long, then we classify that as an integer on the current one. If it's a long double, we have to go and check what the long double is. If it's a quad, then we have to SSE. Double extended, we go to x86, and a normal double, I guess that's SSE. Right, so if we have float and 1, 2, blah, blah, so those are fine. So if we have two registers that we want to process as ones, and maybe we have like one register, well, if the first register is if it is an integer, if it's a normal integer, just fill out the first one. If it's a float or a double, it's an SSE. If it's one of those longer ints, big int with 128 bits, or a longer double, this quad thing, not a double, a quad, then we just put that in both registers. Okay, so now we have classified these, right? And this is not possible. I'm just going to check that. So if it has no class, so then we get low part is just padding, it takes no register, leave. Yeah, so the low part is nothing. Now it doesn't have a class. So here we have, if the class is memory pass the argument in the stack. If the class is x87, x8 up, or complex x87 is passed in memory. And this is not possible. So needed int. If the class is integer, then we go through the registers 1, 2, 3, 4, 5, and take 8-bit type based on the preferred type. So alright, so this is, yeah. If you want to, you can use only if the rest of the goodness in the source type is just tail padding. So based on the preferred type, we want to pick an 8-byte type. Then we extend the type. Right. But will this actually assign something to a register? So okay, so this is crazy. Right, so if I get this correctly, then what we yeah, so I'm just going to go back to the code here, to my stuff. Right, so let's see if I can get up to actually change Windows again. It seems to be slightly unhappy with that. Yeah, soon-ish. Sorry about this. I'm trying to change the screen here to the right application, but it is hiding from me. There it is. So, okay, so what do we need to do here? Whoa. So this is going to be huge. So the way things work right now is like it only thinks of this, right? It says, okay, if the return, oh, this is even hard coded. It should like be like size of type size, type use size, right? So this is not even true. So we have to write something here and sort of decide what we do later. So x64 is going like this. So we have like first look, first classify the arguments. So we have like int, we have SSE, we have like x87, and so on. And we have a top, up, high and low version of those. Two, we have to sign and extend those correctly. The parameters correctly when passed registers. And three, only there's like this ordering to it, I think. So I think if I just go back to the Godbolt thing, you can't see this, but let me just open that for myself here. I think the Godbolt thing said if you have like a double, I have to switch. So if I have a double first and then an int, let's see what that transforms to. So double, a double and an int. If you pass that, the first one becomes a double and the second one becomes a I32. So, but a float, but a float which would be smaller, that would be, if you have a float, then that is an I64. So like, if you do like others, we could like basically do like float plus I32 becomes I64, right? And then we have like a double plus an I32 becomes a double and an I32. And what about like a float plus a float? That is, I don't know, what is that? That is 2x floats. And double plus a double, yes, according to this. So that would be double, double. And if we have like float, 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 and then doubles, then that would be like oh, you still only see X code. Sorry about that. Let's see if I can change this. It's like refusing to give me the list of windows mostly. I just get a flash, and then it goes away. Sorry, I'm trying to work around this bug in Twitch Studio. God, annoying, slightly annoying. Yeah, now I got it. Oh, let's see. Let's just keep this working just a little bit longer. Maybe I can find it. There it is. Please change. Right. Now it changed. Right. Okay. So this code here is not from obviously not from what I just read. I understand this now. Why it is like this, because I read the code, but I can't really say 100% that this is correct. So what I'm doing now is I basically write down the rules as far as I can tell from using Godbolt as an oracle. I'm just going to check what happens if I have like a small thing, like a byte or something. Put a char. Let's see. So if I put anything like any int plus a float, any int like a less than 32 plus a float, and that becomes an I64. And like if I have two chars, I guess like if I have a bunch of chars, characters, something. I see. Oh, so now I just put like hang on. Right. So any int total less than 64 plus a double becomes I64 plus double. And then we have what happens if you straddle things. So you have a short and a short. Let's see. I'm just going to. What did just happen? Right. So this is this was interesting. I actually see. This is something you don't see every day. So I'm just going to like this. If you have like char and like byte plus byte plus short plus short. It actually sends you an I48. And I don't see how this could be correct. Oh, how does that even work? There is like, doesn't make sense to me. All right, so let's see what that looks like. Even square it when you call that one. If I call it, just going to write something in the other window here and see what happens. So I'm just curious as to how, like, what will it do when it wants to send that data? Oh, okay. All right, so I was in the wrong window. That makes sense. Okay, so I'm going to call that one the I48 one. Yeah, it basically just, it makes an I48 call, and so it apparently does the right thing. I mean, in the call later on, but it doesn't. I mean, it seems a bit insane. So I'm just going to, what happens if I just take a few bytes and then so I have char right, so if I just straddle that and it can't get a good alignment, it just throw it up and say, okay, it's an I64. But if it can, then it tries to have first an I32 and then an I16. Yeah. So it's actually, I don't know, if I just put a short there inside. If the short is a 16, right? And then I add a char. It's obviously I32. Right, so it actually tried to make it as small as it can. I thought this was true, but this is just because the double is there. So if it's just the bytes on themselves, then it will try to keep it short. I don't know. Like, is this? Can you, like, are these all the rules there are, or is there something else? That's what I want to. Something I wonder. I mean, if you do, like, let's say you have a double, and then you have a byte and a byte, and the short, and the short. Like, will this be double plus I48 or 64? I think it's this. I think like allowed have like yeah. So that was, my guess was right. So if you have a double 4, like if you don't have just all of these bytes, if you have just ints, then you can pack it like that. But if you throw in a double, for example, then all bets are off. So it doesn't, they just, okay, whatever, I sort of give up. That could also have to do with the fact that the struct now has to be aligned 8-bit. So it's like, okay, whatever, I just going to align this stuff. I mean, the alignment on a struct that looks like this is going to be 16, right? So it can do this. But if you have this, we have the alignment, which is 8. So it goes to getting this one. It's like it has to be aligned as well. So that could explain things. So it looks for alignment basically. And to test that, I'm just going to throw in a float first. When I do that, it's just going to put everything and says like, okay, this is an I64. So that was sad. What happens if I have like 2 floats and then I have my 48 bits of ints. All right, so that was a bit sad. I can, if I do like this, so if I have like float plus float plus byte plus byte plus short, that would give me 2 times a float and then a I32. Oh yeah, that makes sense. And if I have like a short, another short, you can't, since I don't have a, if I just add a short here, it will, you can't do I48 because the alignment would not work because float is aligned with like a 4-byte boundaries. So then it obviously becomes I64 there. But if we have some, you know, the 16 float that is smaller, I don't know if we can define that. I have to look it back, see if it, what was the name of that one. So if you have a float type, you have this. I mean, if you had this 16, this half, there's a half precision. There are two 6 currently used 16-bit floats, and one is called half usually, and the other one is or float 16, and the other one is called a brain float. So it looks like I can't get to that one. Let's see if I can classify that one. So I have long double and the floats and the double extended, but we don't have the small ones. Like, I don't think we have 16-bit. Right, the vector types. Just now looking at the implementation again for Clang. So if the size of an object is larger than 8 bytes, it's okay, that's a huge thing, then it doesn't matter. So we also have the bit fields, of course, but that won't be a problem for C3. So I think I actually got through most of these rules now. Okay, let's see if I now have written it down like this, these rules. It would be interesting to know what the rules are for x32, for the 32-bit versions, but we have like rules, and now I guess we have to sort of, I know how to implement this because we have the signature, right? So this makes sense. but we also have, that's what we want to deal with. But we also have what we want to do, what we have to do later on when we take on actually making this into something for LLVM. And this one should probably not be here because we don't know what the ABI, well, actually we know what the ABI is. I didn't need to, because I think so here we do the func time, and then that's when we already it's much later. So this shouldn't be here. Move. Right. So instead here we're gonna move this to, let's see here, analyze, like here, right? So now we need to do this differently for every for everything. Oh, how do we, when I call this, I'll actually look at these return params because I need to do stuff when I do the call, right? So like here, I'm going to emit something and put something in place here. So I need to have this calculated actually somewhere, which means this maybe should go in here anyway, back in wherever I have that. This will make the signature much crappier, I guess. But like this one is super simple, because if it's void, it's not void, then I'll just look at the size. But again, we have some places where they don't care about that, and it's this is just for it's just for that API. So we need to ask that. So we're going to put this somewhere. We have target something, target setup, target something. Let's see where we put all the target stuff here. So these are the architectures, right? And some here, some we have this one. I just prepared it, but I never used it. So find usages. So I wonder if at this point in time, do we know what the target is? So it should be in its context. Do we know what the target is? We know what the build target is, right? But the build target has a type, all right, but that's not interesting. So do we have something else? Build target. I think that maybe the target is basically something you can get. Target. Oh, great. Build target. Yeah, that was helpful. That's the back end thing. But we have this target. Somehow, maybe we use that somewhere. Find usages. Built-in setup. So we have build target as a freestanding thing. So we can get the build target. It was a long time since I used this, obviously. So maybe we should say like, okay, what is like a max size for parameter return, or for max size for return. Okay. So if the type size is greater than the max size for return, then we do it as a return parameter, right? So all we need now is to define that. We go to the build target, we define that max size for return. We want to define this as well. And it looks like this one isn't. I think I basically did some yes here. So I just going to do like this, switch on whatever the build target architecture type is, and if it's a case type arc type x86-64, then it's going to be like let's see, that's going to be like 16, right? So that should be a function. Oh, no, it doesn't need to. Just do it like this. So in that case, build target max size for return is 8 times. Like this is going to be like a build target pointer width of a pointer. I don't know if that is the it's going to be the bit size. So it's going to be like a times of pointer times 2. And maybe that's true for some of the others as well. But for now, it's just going to go for like some weird number. Right. So this is going to be wrong. But now it should be using the right thing. This is going to be like 64 and 28 divided by 8. So this is the max size for return. So that's for the return, right? And then we have, then the other thing would be like how you actually pack the arguments. And I can do this here. That basically needs to be something that you do elsewhere. And I could actually, have a look using the compiler explorer here in Godbolt and then see like what do they actually do. So I'm just going to add a few more targets and see where they sort of end up. So it's going to so I am now in Godbolt and I'm running x86-64 and I am returning a foo somewhere. So let's return a foo from a function, foo get foo, and we return the foo, an empty foo, and then we have some function that's taking that one, foo x is get foo. And now I'm just going to see what happens. So the get foo is it is fine with returning that. So we're just going to give like an int, and it is so int is returned. 2 ints are fine, 3 ints, 4 ints. If I correctly, that's going to be fine. Yeah. And then when you bring in like a small, tiny byte, what I can do is bytes. So you have a char, and I have like 8 chars is fine. Ugh, I have some other code that I don't use. Just get this compiling. Right, so 8 are fine, 16 are fine, 17 are not fine. And let's see if I can get Clang on 32 bits. No. I can get Clang on PowerPC. Let's see what happens. What? So on PowerPC, they actually return that by value no matter what. So even if like a struct is a, yeah, it's going to be like for PowerPC. So for PowerPC, PowerPC, and that was 64, I think. PowerPC Clang, yeah. So it's going to be 0. -1 actually. And that's bad. So unsigned is a bad choice here. So we actually want to do that. But then we have to be careful when we do the comparison, right? Because the type size here. Yeah, so we have to, let's say that's 0, okay? So if the type is bigger, it's like it's either build target max size for return is 0, or type size is bigger than that. We put this to unsigned now, and we're fine. So if it's 0, then we always return that. So this is correct actually now. And we have to do break. Otherwise we're going to have some fun. And let's see if the other things with PowerPC is the same. Let's going to check. Let's see what I have here. LE once. No, the PowerPC LE is fine with this. So let's see what it does with a char 2. Yeah, it's fine with that. 4, 16. Right, that's fine. 17. No. So Power64 LE is not doing the same thing. It likes this arch type PPC LE. It likes this style, right? And then we have, I don't know if we have something else here that I can, just check out right now. Let's do RMV. So let's do RMV7, and it is always returning. No, if it's a char, it's actually returning that as a char. If it's a double, it returns it as, oh, double wasn't okay. So an int is okay, but a long is not okay. So for ARM v7, ARM, I guess this is ARM, so that should be like, it would still be correct, right? Because what's the width of the pointer for an ARM v7? Yeah, that makes sense for the ARM. I'm just going to like assume that that's true. ARM B, okay. So here, of course, ARM v8 is fine with this style. Let's going to look at some other type of processor and see what the RISC-V thing. It is fine, actually. The RISC-V, they're both fine with longer terms. So int a char, int a, int b is fine, int c. Actually, that one returns something unexpected. D, E. Yeah, so it for RISC-V, 64-bit, then it goes 64 and 32. It just makes sense. It's just correct as well. Case archetype RISC. This. So those are fine as well. And I suppose that this should be true. Someone has to prove that it isn't. And then we can just do it like a fatal error. Unsupported. Right. We got somewhere. We didn't get anywhere close to done, but I sort of looked at the complexity just on x64. This is not the only thing. This is just this is like small, and then we have the other ABIs as well. So this is just some peek at the complexity here. And the interesting thing is whether I should look at this or should I go to Clang or something, because the actually reading Clang is not really fun either. Maybe the specification is easier to look at. But maybe this gave you a bit of an insight on how it looks like when you try to do this stuff to support the structs. And I mean, I think this is something that should be in LLVM, or at least be offered. Like, okay, you can have this behavior, and you can query it to some way. But this is hidden in Clang instead. All right, thanks for wait. Hang on. Maybe if there is some question, does anyone want to ask me anything here before I shut down? Give you a few seconds. But the fun thing here, I think I showed that, is that obviously ARM is doing something else, and we just saw that PowerPC is also doing something else. So everyone is doing different things, and I mean we can't really do this in like a really simple way, because these are not, rules that you can like compare with easily. These are behaviors, right? So, well, these behaviors affect both the caller and the callee. So that we have, we have several places where we have to fix this. So first it does this, try to figure out how to move these about to put them into the parameters, and then the call function would need to extract them and put them in the right order. So we have to do this in different ways here, and this is why also vargs later on, they only accept certain types, right? So they handle differently again. Anyway, so this, I'm going to quit here. I hope you had some fun watching this, or at least you got some insight into what's needed and the amount of sheer amount of code that's handling this in Clang. All right, thank you for watching.